I'm Bryce Bible, UB's Vice President and Chief Information Officer. I'll be sitting down with students, faculty, staff, and other thought leaders outside of UB to highlight some important technology topics that affect campus community members like you. Let's take a ride in one of our electric Tech Squad vans and meet our guest today. Our guest today is Dr. Peter Elkin, Professor and Chair of UB's Department of Biomedical Informatics. Peter has been actively researching health data representation since 1987. He has also been at the forefront of COVID-19 data research, and as you'll soon learn, he is also teaching others about the application of AI in healthcare. Well, Peter, thanks for joining us on Tech Talk today. It's a pleasure to have you. Good to have a chance to chat with you.
It's great to be here, Bryce. Thank you for having me.
We'd like to start with you just giving us a little background on yourself. What's your journey that brought you to UB, and then what is your role at UB as Professor and Chair of Biomedical Informatics?
It is interesting. You know, biomedical informatics is a field that is relatively new in medicine, and clinical informatics is now a board-certified specialty, and it was a journey getting here. So when I started out with this, I remember people would tell me, Peter, you're a good doctor. Why would you want to do that for a living? And now people come up to me and go, hey, how cool. How did you think to do that for a living? And honestly, it's been a wonderful journey, and with great people, nice people in the field. And basically the vision originally is the same as it is today, that we can use information technology in smart ways by combining workflows and make the practice of medicine safer and more effective for patients. That includes new therapies for people, better ways to predict how people are going to do to get them in the right care pathways, and getting clinical guidelines to actually be utilized more in the practice. And after that, we've created things like precision medicine. We've created things like the biomedical literature, which is now open and available to everybody, which revolutionized the ability to use evidence-based medicine in the practice. We've been involved with creating clinical and translational science in the country, and that has been a labor of love. And I'm proud to say that I'm now the new editor of the Journal of Translational Research, and I'm looking forward to that. I think that's going to be a very exciting chapter in my life. And we have an outstanding editorial board. I think it's going to be a high-impact journal. I have just completed now my term as co-chair of the Enterprise Committee for the National Center for Advancing Translational Sciences at NIH, and that's also been a labor of love, and we've had great successes with that. I did my training at Harvard and computer science at MIT, and then took my first job as a faculty member at the Mayo Clinic, where I rose to full professor, and got recruited to Mount Sinai in New York City as vice president of the hospital and center director. And then UB opened up a department and was looking for a department chair. And it was a unique opportunity for me to build a department in my own vision. And I was so grateful that they offered me the job. And we have been very successful. We are now in the top 10% of all medical schools in biomedical informatics.
Wow.
Not only our CTSA award, but we have T15 training grant from the National Library of Medicine. We have an R25 training grant from the National Library of Medicine, and we also have an ACGME accredited fellowship in clinical informatics. Those things together, there are only 4 institutions in the country that have that grouping. And so we are considered a top program nationally. Our competitions are Harvard, Yale, Stanford, and Columbia and Penn and the kinds of places that we consider some of the top institutions in the country. Our goal is to get UB into the top 25 AAU institutions, as per Dr. Tripathi. We're very excited to be part of the solution.
What a great background, Peter, and how lucky UB is to have you and building the programs you are. You mentioned the National Library of Medicine grant, which provides students opportunity to learn more about bioinformatics or biomedical informatics. So if you could talk a little bit about that, how does that help students?
Oh, it's amazing. So when you have, this is a graduate program, so you have a predoctoral PhD students, and we have postdoctoral fellows. And what that does is it energizes our research programs, and not just in our department, but across all of the departments of the School of Medicine, and actually we collaborate across all 10 decanal units.
Okay, so it's not just medical school, it's all many of the health
and
schools.
These people, they teach, they do research, they collaborate, and they're all funded entirely by the NLM grant. We get postdocs for 2 to 3 years, and we get the PhD students for 4 to 5 years of funding, and that gets them right to the finish line. And we've had outstanding people. I mean, one of my last PhD students, she went off to Yale to do her postdoc, and then came back and now is faculty over at Roswell.
Wow.
So we have great people, and a number of our fellows have come on faculty with us and are just outstanding clinical investigators, really, really good people, and we're very proud to have them.
That's great, and thanks for sharing that, because you talk a lot about the research you do, but this is about how the next generation of practitioners are going to be successful, and of course help us as we all need healthcare.
If you'll allow me, our R25 program is a program that takes undergraduates and master's students, and it's feeding the pipeline. It pays them $5,000 in the summer. They have to be U.S. citizens or permanent residents, but they can get an experience over the summer in biomedical informatics, and we hope that leads more people into the master's and PhD program, and that we fuel the pipeline of education to get really excellent people out there. And there's huge need. Everybody's getting jobs. There's a tremendous amount of potential in terms of hiring. We have 6,000 hospitals in the country, and all of them are looking for CMIOs and chief medical information officers and others. So we're really very excited about the opportunity for our students, and great careers ahead for each and every one of them.
That's great, Peter. So I want to pivot to something we all want to forget about, but it's not gone, which is the pandemic and COVID-19. And I know you had a lot to do with the research part, and particularly developing a national database on that. Can you talk a little bit about that? Because we all know that there's data associated with it, but I think understanding more of how you and UB's been involved in that is really important.
This came out of the CTSA consortium, and there were 64 hubs involved in this. But some people, even outside of the consortium, contributed, I think up to 75 institutions. And what happened was that we compiled a database nationally of everybody's data on anybody who'd been tested for COVID-19 in a case cohort control trial. And this has led to a myriad of papers. The White House cited it, best practice, and it's been a source of pride for NCATS. And now they're moving on to do what they call the Tenant Project, which is to move to other diseases and to try to do it in a more comprehensive way so that we can find out rates and denominators. And I think they're moving in exactly the right direction. We need this to happen. Yesterday I heard a talk by the acting director of the National Library of Medicine. I'm on one of the boards, and he actually is looking to use that kind of clinical data along with genetic data to create an infrastructure for research that will really, move us up to the next tier in terms of our ability to discover quicker and more effective cures for patients.
And that really leads us into my next question. You're talking about how data collection or use of data has changed. But I've known you 10 years, Peter, and I know the use of technology, and particularly data collection, and then how you can use it has changed.
You're absolutely right. And that, people don't realize it, but the whole AI revolution is predicated on the fact that we have cleaner, better sources of data, better indexed data, that we are starting to use ontology more in order to organize our medical knowledge. And this is a great opportunity for UB, and it's a great opportunity for the nation to create a safer and more effective healthcare system.
We couldn't talk about technology today without AI, although most people it's still very voodoo-y and exactly what does it mean. But talk about it from a healthcare point of view. You led a workshop not long ago on the topic itself, but I think trust is a question, particularly when it comes to healthcare, right, in the use of AI. So talk a little bit about what you're seeing and what's going to have to happen for it to really be a trusted solution in healthcare.
Now what we have is we have predictive models from data that comes in that can create matrices and vectors that tell you what the likelihood of a next piece of information is given a set of prior information. And what happens with that simple concept is that you can learn in a left to right, top to bottom fashion what things are saying. And when you get that, it can be very powerful. It turns out that with large language models with lots of intermediate layers, what ends up happening is you get interactions that allow you to understand how things relate, not just on a primary level, but on a secondary and tertiary level to each other. This sometimes brings out fantastic things, as we've seen with ChatGPT and GPT-4. It's very exciting. New developments that are coming up in this include using knowledge graphs and trying to create semantic AI, and we're right in the middle of that, putting that together. We've got collaborations with Stanford and the Ohio State and MCW on project to do just exactly that. We have a project that we're working on with the Department of Veterans Affairs and the DoD, called part of the Apollo project from the President. And we're also very excited about a few other initiatives around that are under review currently, some very large grants that are being reviewed currently, like the ARPA-H data fabric, which we are hoping we will be awarded. Now, when you think about, so what are the challenges ahead and how are we going to solve them? So this comes up at every single conference that we're at these days. And my answer to that is, the number one answer to this, before I start telling you what the problems are, is that we're going to solve them as a community. We're going to solve them together. We're going to solve them by creating conversations and experiments that need to happen in order to get to the bottom of how to do this best. I'll give you one example. We talk about fairness and trust in AI, right? So there are two things about a trust in AI, right? You've got to trust it for what it can do, and you have to trust it to be safe, okay? So part of the safety problems that we've seen is that, for example, if you train a system on a population that's different from the population you'll be using it on, you can get very biased results. We've had some systems that were trained in Norway on Caucasians, and when they're used on African Americans in the United States, it didn't work very well. And these we are approved by the FDA. I mean, we have 500 approved AIs already by the FDA. I believe we're going to have over 10,000 by the year 2030.
Wow.
The whole goal initially will be to, like when you go bowling, you know, you can put up those guardrails so you don't hit a gutter ball. We want no doctor to throw any gutter balls. We want the AIs to be around them to help prevent gutter balls, so they're always hitting the pins. And then we're going to narrow that down so it's always a strike, you know? And the goal is that at the end of the day, we need to work together to have safe and effective healthcare that's relevant for the population using it. So there are a number of strategies that have been developed in order to try to decrease bias in AI algorithms, make them trustworthy for people. So for example, people can look at the populations and then do cross-validation to understand the effectiveness across individual populations of algorithms. And there's two ways to approach problems that you find. One is you can do population balancing, and the other is that you can separate out populations that need their own special algorithm and make an algorithm for those populations and know that you're going to run the right algorithm for the right people. So we've got 10,000 of these algorithms. Who knows the inclusion-exclusion criteria for each of them? Who knows what populations they were trained on? Who knows the sensitivity and specificity of their effect on what they're trying to predict? And who knows what the pathways are, the ways they should be implemented? And those are clinical informaticians. They're the people we are training in our ACGME accredited programs. And it's my hope that we can develop clinical, actually, services that are like a test, like an echocardiogram or a stress test, where people will do a informatics biopsy, and that informatics biopsy will run against all of the AI algorithms that we have, and then come back with recommendations and a report from a clinical informatician that they would sign and give to the teams in the hospitals to help them care better for patients.
So now we have expertise that needs to come out of the programs that you've got, which it needs to grow greatly because we need those experts, right? That can help guide the docs. But then the medical practitioners need to also understand how that was developed and how it was used, because they'll ultimately need to make those decisions at the end.
They need to know.
So AI is not going to replace you as a doctor.
No. It's to be used with doctors in order to do well caring for patients. Now, there'll probably be some edge cases where they'll help. Let's say we have very rural communities or places in the world that don't have access to good medical care. Then maybe that's the best they can access, is to trust in AI, and it will bring subspecialty level care to people who never had it before. And I think that those experiences will inform how it moves forward. But I agree with you, doctors are not going to lose their jobs. The problem is, if you look at care across the entire world, it isn't what we want it to be. Yeah. We need to make it better. It's a international imperative. We want to contribute in the ways that we can in biomedical informatics in order to not only protect the safety of patients, but also to create methods to get the right care to the right patient at the right time.
I'm going to want more and more of my data available into these systems, because that allows the system to let my physician know that, oh, here's an alert about Bryce Bible based on our algorithms. So I want more testing. I want to be able to have everything I can possibly have in there, seems like, doesn't it?
Plus you want to do that for your family members. Like,
absolutely.
I would love a button, that people could press that says, is my mom getting all the care she's supposed to?
Yeah.
And just, make that happen, and then it comes out. Then I'd like whatever she's missing to be loaded into the task list for the doctor so they can approve it and make it happen for her automatically.
So from a program point of view, from the bioinformatics program, you've given some indications here, but what do you see as some of the technologies that, AI being one, but what else is in front of us related to your field?
Oh, it's wonderful. So one of the great promises that's been made through the NIH that hasn't been fully realized yet is clinical genomics. And we've done a very good job in categorizing and understanding the way to represent genetic information, whether it's epigenetic or genetic or even gene expression data or proteomics. What we haven't done a really good job in yet is matching that with equally well curated clinical data.
Yeah.
As we do that, we're going to be able to get narrower and narrower phenotypes and the subsets of people that have particular genetic signatures that would say that the best treatment for them within a class is this particular drug rather than these other ones. Or the greatest chance of toxicity is here and we should be avoiding those medicines in this individual. And people need that for safe care. This is part of patient safety. And I think it's a sworn duty of the field to make that better for everybody. Doctors need to know outside their specialty when to refer, what they can trust, but they don't need to know everybody else's specialty entirely. Yeah. It's just too much to know these days. So we need to create a service line that helps all doctors utilize this kind of information in a way that helps their practices.
And I know this is a research area that you and I've worked on, which is around quality control or quality integrity, which sounds like that's also extremely important. And not that the data is not there, but I think we're starting to find that the connection between all the different sources of data and then ensuring that it's correct is so important.
Data quality is paramount. It's number one.
Yeah.
And it all starts with well-curated and well-understood data, using cross-validation where we can to get multiple facts to generate information and our sense of how sure we are that any fact is a true fact is an important thing for all of us to work on. It's an opening in the field where we have a real opportunity to do well, and it turns out that UB is well positioned for that. We have one of the strongest ontology groups in the world, and working together, we can contribute to how the knowledge representation for this kind of information is utilized within side of medicine, and actually in other fields as well, because ontology obviously stretches into engineering and manufacturing and other areas too.
You've given us a very positive view, which I like, about some of the emerging technologies and then what can happen, particularly around AI. And that's good to know, especially coming from an expert like yourself. So thank you for sharing some time with us today.
Oh, it's been absolutely my pleasure.
Been great to have you here. It's good to see you. Thanks a lot, Peter.
Thank you, sir.
Thanks for watching this episode of Tech Talk. Check out our other episodes online anytime at buffalo.edu/ubit/Tech Talk.